I purchased the PM-30 mill from Precision Mathews back in the fall of 2021. I had previously purchased a mini metal mill which was just too small for the machining operations I needed. I needed a larger metal mill. This mill is significantly larger, weighing in at about 600 pounds, and it does require 220-volt power. It has an X travel distance of 23 inches, a Y travel distance of almost 9 inches and a Z travel distance of 14 inches. This is a manual metal mill, which I was planning on converting to a fully operational CNC-controlled mill for the machining of aluminum, plastic, and other metal parts. This was my very first venture into the automation of my shop tools. I did have a lot of help for this conversion, including numerous YouTube videos as well as help from the manufacturers of the components. This project provided me with knowledge on the operation of servo and stepper motors as well as the computer control of these systems. I was able to build upon this knowledge for the design and development of my other future automation projects. I will not go into the total details of this CNC conversion of the metal mill since I produced a 3-part video series back in 2022, which fully describes the disassembly of the mill, replacing and installing the new ball screws and stepper motors, and the design and construction of the electronics cabinet. A final video demonstrates the operation of the computer system to operate the CNC converted mill. Below is a brief description of each of these 3 videos. In the description section of this video, I will list the titles of each of these videos as well as the web link to the YouTube video. Also, in this description section I have included references to other YouTube projects that I have completed using this automated mill to machine the parts for these projects during the past 4 years. This automated CNC mill was extensively used to machine many parts for the 3 other tool automation projects described in the 3 subsequent videos on the automation of tools for my shop. This video is the first in a series of videos that describes the design, assembly, and testing of the electronics system for the mill CNC conversion. I laid out all of the components for the servos on a metal panel which will later mount into a 24-inch by 30-inch metal cabinet. The first component is a circuit breaker, followed by an EMI filter, then a contactor followed by a second EMI filter. These all connect in series, which provides for a safe and clean filtered power line to the servo controllers. I provided cable channels for the organized wiring of the components and some terminal strips for wire connecting the various components. As shown here, I originally included the Centronics computer board and power supply on this panel. However, several months later I added a 4th servo controller to this panel for the control of the servo motor for the spindle motor. At that point I moved both the power supply and the Centronics computer board to a separate small box. I did this to make more room for the 4th servo controller and to be certain that there would be no electrical interference with the computer board which controls the operation of the entire system. I mounted this panel containing all of the component into the metal cabinet which was mounted on the wall next to the mill. A more detailed description of the electronics assembly can be seen in the referenced video. The web link to this video is listed in the description section of this video. In this second video in this series I described the complete disassembly of the mill, removing all the existing ball screws, and removing the table and saddle. I described the complete installation of these components and the problems that I encountered during the installation. For this conversion, I purchased a PM-30 CNC kit from Arizona CNC Kits designed to fit the PM-30 mill. This kit included 3 ball screws with double nut ball couplings and an adapter motor coupler plate, one for each of the 3 axes designed to fit my Precision Mathews PM-30 mill. These coupler plates will fit either NEMA 34 stepper motors or servo motors. I disassembled the majority of the mill as was shown in this video, and I replaced all of the screw mechanisms with these new ball screws that were included with the kit. This disassembly and reassembly was a challenge due to the weight of the mill parts, and it did take me about a full day to complete. I elected to purchase the 3 servo motors from DMM Technologies. The feedback from others who had done this conversion is that the servo motors would be more accurate than the stepper motors. However, in retrospect, I think that closed-loop stepper motors would work just as well, and the stepper motors are less expensive. The servo motors mounted directly to the NEMA 34 coupler plates attached to the ball screws. The web link to this video is listed in the description section of this video. This third video in this video series shows the completed CNC mill conversion, demonstrates the software operation and the completion of some milling projects. I had previously constructed the table for the mill, which includes drawers under the tabletop for the storage of the mill components. I built a cabinet to completely encase the mill in order to control the flying metal chips that are created by the mill. I made the frame for the cabinet using 2020 aluminum extrusions and then used a 1/4 inch thick clear acrylic plastic panels to enclose the system. I only enclosed the front 3 sides of the mill, and I made 2 large doors to gain access to the mill. I did leave the top open and installed an exhaust fan which vents outside of my shop. I also added a coolant misting system which uses a water-based misting spray for my machining operations. Based on the design of my cabinet, I was not able to use a flood coolant system. However, if I were to remake the mill table in the future, I would definitely design a table to enable the use of a flood coolant system with a drain and recycling system. To control the operation of the CNC mill, I had purchased the hardware and software kit from Centroid Acorn. This kit included the software for the operation of the system plus the main computer control board. For some of my projects, I have downloaded the G-code software generated by the Fusion 360 software for the control of my machining operations. However, I usually use the conversational programming, called Intercon. This conversational programming is especially easy for programming the patterns for holes, countersinks and thread milling on the many aluminum plates that I have made for my systems. In addition, if I ever need to make a change to any dimension, it is quite easy to make the changes in this Intercon software. This third video demonstrates my first 2 jobs using the converted CNC mill. The first project demonstrates the machining of some soft jaws for the mill, and then a second program demonstrates the machining of some mag jig mounting plates. I used the Centroid Acorn Intercon software to generate the program for the mag jig plates. I have been using this mill extensively in my shop to machine the parts that were required for the design and assembly of the other automated machines, which I will be describing in the future videos in this tool automation video series. For most of my machining I have been using aluminum, but on occasion I have also machined some other materials including brass, steel and Delrin plastic. I also purchased the Fusion 360 CAD/CAM software for designing my projects. This software does have a steep learning curve, and even after 4 years I continue to learn new features of this software. This software enables the 3-dimensional design of my projects, and it can also generate the G-code which can be downloaded to the mill for the machining of my designed projects. In addition, this software was an excellent tool for the design of my projects for my bamboo 3D printers. What I find myself doing more and more is designing my projects using the Fusion 360 software, then printing out the designs using my 3D printers. This gives me the opportunity to test out my designs before I actually machine them on the mill. This saves time and controls the cost of the metal used to machine the parts. In 2023 I made a few changes to the CNC mill. The first change was to add a servo motor for the operation of the mill spindle. This change permits the complete automation of the spindle speed and operation. When a program cycle starts, the program automatically starts the spindle at the programmed speed, and when the program cycle ends it turns off the spindle motor. The second change was the modification of the electronics to encase the Centronics computer board and its power supply in a separate metal box to electrically isolate it from the other electronics. The cabinet on the right is the main cabinet with the 4 servo controllers and all the circuitry for these controllers. The smaller cabinet on the left contains the Centronics computer control board and its power supply. On top of that is a smaller box with the KB Electronics KBSI 240D signal isolator. I machined a custom mounting plate for the servo spindle motor consisting of 3 parts, a bottom large plate and 2 standoff plates. I also did make a few other additions to the system. I used my 3D printer to print out some custom cases to enclose the cable connectors on the servo motors. I then used some caulking compound to seal the ends of these cable connectors to keep any solvents or chips from getting into any of the connectors. I also used my 3D printer to create a new custom cap to cover the end of the spindle. This is my first machining job using the new servo motor mounted on the mill. The first step is using a drill to drill 2 0.201-inch diameter holes. I'm running this at 1000 RPM. And then the second step is using a thread mill operating at 2000 revolutions per minute to tap 1/4 inch threads at 20 threads per inch. But when the spin cycle ended, it actually faulted out the servo motor controller in the main cabinet. This is another close-up view of the machining of the same pieces. Again, after the spindle operating at 2000 revolutions per minute for the thread mill stopped, it faulted out the spindle controller. Subsequent tests determined that the maximum speed of the spindle servo motor is 1500 revolutions per minute to prevent this faulting of the spindle servo controller. Any faster than that causes the servo controller for the spindle to crash. I would not recommend the use of a servo motor for the operation of the spindle on the CNC mill. In the future, I will probably replace this servo motor with another type of motor to enable the operation of the spindle at higher speeds. This concludes this first video on the conversion of my Precision Mathews PM-30 mill to a fully operational CNC mill with servos to control the X, Y, and Z movements and a fourth servo motor for the mill spindle operation. If you would like to see a more detailed description of this conversion, please refer to the 3 videos on this conversion referenced in the description below. Also listed in the description below are several other videos in which I use the CNC mill for some of my other machining projects. There are 3 additional videos planned in this video series on the automation of 3 additional machines for my wood shop. These include the automated Accu-Slice system, the automated Rose Ornamental lathe, and the automated CNC Router. These videos should be completed by the end of 2025. In general, I have been quite pleased with the operation of my converted CNC mill. I use it quite often to machine parts for projects in my shop, and I used it extensively for the machining of parts for the other 3 automated machines for my shop. However, as I mentioned earlier in this video, I do have a few recommendations. First, I would not recommend the use of a servo motor for the spindle operation since the maximum speed of operation is 1500 revolutions per minute with the spindle motor. I am currently searching out a VFD-style motor for my spindle. Second, I would probably use NEMA 32 closed-loop stepper motors for the 3-axis. These motors are significantly less expensive and should operate as well as the servo motors. Third, I would recommend a cabinet and base for the mill with a tray and drain to permit the use of a flood coolant system. This is especially important if you are machining steel or iron. Fourth, if you are installing the CNC ball screws, you will need help in this installation due to the weight of the mill. Once again, thank you for watching this video. If you have any questions, please email me with your questions.